Hello, my name is Daniel, and I'm going to show you what I did for my networks project. This is a game where two players play as planets orbiting the sun, and they have to shoot lasers at each other to score points, and they can block those lasers using a directional shield that is activated with right mouse click and moved with the A and D keys of the keyboard. First of all, I'm going to show you how it normally works, and then I'll show you what happens when you try to interfere with the networking of the game. Since this is a peer-to-peer TCP application, one player has to temporarily act as the server in order to establish a connection. When you try to interfere with this stage of the application, lag will only cause the connection to happen later. Drop will have no effect since the packet will get resent, and the rest of things will have also no effect since TCP is acting against them, except for tampering, which always seems to be causing problems with the information inside the packets. First of all, let's enter the IP we want to connect to. And this is how the game should normally look. You see yourself as the Earth planet and your opponent is the lava planet. You can shoot lasers at it, they follow a straight line, and you can block with the right mouse. It spawns a shield and you can move it with A and D. In the left in the left corner you can see measure for latency. It is actually the latency for the last packet sent, not like the current one. And now let's see what happens when we apply interference. I'm going to first use a latency of 350 milliseconds, and then I'm going to apply various effects with a 10% chance of happening on every packet. First it's going to be dropping the packets, then it's going to be throttle, which will send all the packets at once every 300 milliseconds. Then I will triplicate the packets and see what happens. I will send them out of order and I will tamper with the packets. Just a quick comment is that since the application is using TCP, duplicate and out of order packets shouldn't have much impact because TCP already accounts for these, and since I'm resending packets that get lost, well, we'll see. First of all, let's apply lag. When you shoot lasers, they get there late, 350 milliseconds late, and so instead of just being initialized at the position they should be in by taking into account the latency, they start at the point where they actually started. So what they actually started, and then the real position they're in is calculated and they're interpolated so they can catch up quickly to their real position, and it doesn't just look like they appear really far away from your opponent, but it's smoother than that. It moves, even though it's quickly, it moves towards the point they should be at. For the shield, we are sending the changes in direction, so it will look like it's continuing the motion, and then it'll realize it went too far, and then it will have to go back, since it's only listening to the last packet it gets. When we get them out of order, we'll see that it might ignore some of them. But let's see. When there's lag, you'll see that when the shield stops, it continues in the other one, but then it promptly realizes it should go back and interpolates, like with the bullets. It goes back quickly and to the position it should be. Like this. What happens when we drop packets is that they will not appear until they are resent enough times that they actually are not dropped. Then suddenly all of them will be dropped and they will catch up as soon as the TCP detects they have been dropped and they are resent. As for the shield, if one of the packets is lost that should change the direction or stop it, it might get later than the next one if that one is not dropped, and sometimes it will look like it's ignoring orders because a packet was dropped and it got too late, and another one had already been used for the instructions. But it pretty much keeps up if there's no lag on top of the dropping of the packets. When we activate the throttle, we can see that every couple of milliseconds they all get sent at the same time. So it has a similar effect to lag in this regard. And as for the shield, we also see that it suddenly looks like spikes of lag because the packets are being sent all at once. But our game will only listen to the last one, and since it has the position and the speed, it will correctly predict where the shield should be. When we try duplicating packets, TCP will ignore the duplicate ones, or triplicate in this case, so there's no problem with this. If we send them out of order, it will look like some of them are laggy for the shots, for the laser shots, and as for the shield, it might ignore and quickly have to interpolate the position of the shield. And when we tamper with the contents of the packets, weird stuff happens. The laser shots appear at wrong positions with wrong directions. The shield has a weird velocity, too fast. It starts spinning around. The orientation is messed up. And the tampering of the packets will also interfere with the scoring. So if we score a shot and it is tampered with, the score will be also wrong. It will lose synchronization. Okay, so this is all. I hope you enjoyed it, and thanks for watching.